So now we will move on to the topic of probability. And for a certain probability of something, we can talk about three things. We can talk about the sample space, and this is all possible outcomes. We can talk about an event space, which is all favourable outcomes. And then for each outcome, we assign it a probability. So this would say that the probability of an event happening is favourable outcomes, number of favourable outcomes, over total outcomes. And so now we will think about the idea of random selection, which is part of probability. The purpose of selecting objects at random is to ensure that each has the same chance of being selected. So we're trying to do a fair or unbiased selection. And so the selection of any particular object is said to be equally likely or equiprobable. But obviously, say you had 3 boys, 2 girls, the probability of a particular boy would be 1/5 because you're doing one particular person, but still, for a probability of a boy, would be 3/5 because there are 3 equiprobable boys, but 3 of them, so that makes it 3/5. So that's the what's meant by equiprobable. It's talking about each individual object in a random selection. Now, a probability scale goes from 0 to 1, and this can be in decimals or fractions. When we would do percentages is saying, a certain percent of a large sample have electric cars or something. That would be, and then we would use that percentage as a probability. But generally, you'd want to either do decimals or fractions, and from 0 to 1. And if a set of events contains all possible outcomes, it is exhaustive. And sum of probabilities is 1. Because if you add up the probabilities of each outcome, the probability that you're going to get an outcome is 1, right? So yeah. And then this can be and then from here we can say something that, like, say an event A has probability 0.1. Event that the probability that A does not happen is 0.9. Does not happen would be 1 minus 0.1, which is 0.9. In connection with the idea of exhaustive events, one strategy you can use when solving questions is doing a grid or a table, or what's called sample or an event space. So, for example, a simple case like the difference between two numbers on a dice roll what I would do for that is I'd draw up a table, and maybe if it was on paper I might split it up like this. And then what I would do is I'd do all the differences and I'd write out all the possibilities. So we know that these will have 0 difference. This will have a 1, 2, 3, 4, 5. And then I'd do all of that. And then say if the question asks, what's the probability that it's less than, the difference is less than 2, then after doing all the probabilities, I would then go and I'd circle up the ones that meet the condition. This is doing our event space now. And then I would count that up and then substitute that into the formula of favourable outcomes divided by total outcomes for the probability. And so each repeat of an experiment is called a trial. So when we do a random selection, that's an experiment in a way, and each repeat of that we do is a trial. Now, this can either be with replacement. So say we're picking out 8 pencils, we draw out 1, then after we do that, we put the pencil back in the box and then repeat that. That would be with replacement, but without replacement is we take out a pencil and then we don't put it back in. We just keep taking pencils and thus reducing the number of pencils in the box with each trial. Now, the proportion of trials in which an event occurs would be its relative frequency, and that can be an estimate of a probability that the event occurs. So that would create a difference between something called the theoretical probability and the experimental probability. And we can use probabilities to do an expectation. So like in trials, event A would be expected to happen n times p of A, probability of A happening, times. And so you can use sort of this stuff for like simple probabilities, rather simple cases. And think about, take note of particular words like particular, which would mean a certain, so like a particular boy in, say, this example, as I said, is 1/5, rather than 3/5. 3/5 is any boy. And I should also remind you that with or without replacement is rather important. You could see that if you did without replacement, then suddenly the probabilities wouldn't be equal each time, so repeats of the experiment would not be fair. But for large samples, you kind of ignore the fact that the sample's getting smaller because the sample's so large that it doesn't matter. And just another disclaimer, the possibilities for probability questions, they are kind of endless. These series of videos on probability just tell you a few formulas and a few concepts that you need to nail down and use in answering questions, and you may have to get creative. It's one of the few topics where you do need to get a bit creative.